Today we're going to talk about LeetCode 371, the sum of two integers. But the interesting thing here is that we cannot use a plus or a minus sign, okay? So we need to do this different. A equals to 2, B equals to 3. Okay, how can we add this? So the trick here is to think of binary addition. So we're going to add just like a computer does using binary operations. Okay, so in binary addition, we have these four rules. 0 plus 0 equals to 0, 0 plus 1 equal to 1, 1 plus 0 equal to 1, and 1 plus 1 equal to, it's actually 1, 0. Okay, but this bit, the rightmost is 0. And the carry is 1. Now let's remember this going forward, okay? We can see that this XOR bit operator. So when we do that, when we apply it in this table, just like we did in the addition, it looks just the same, right? 0, 1, 1, 0. Okay, so we can simulate the addition portion of adding the numbers, right? But we forgot about the carry, like we just disregarded it. So we need to simulate that also. Think of it like this. If you're doing addition on a pen and paper, using a pen and paper, right? We do the addition. If we get a carry, first we write the digit down in the place, then we do a carry, right? Like we need to bring that over to the next position, right? So this XOR is simulating doing that addition, that sum, that part where we disregard the carry. So that's what we're going to use, but we need to take care of the carry. So how can we do that? Well, we have another operator that will help identify when there is a carry. Okay, so this AND operator, if we do an A and B, the only time we get a 1 is when there are two ones. So 1 and 1 equals to 1. So if we remember back to the binary addition, 1 plus 1, that was the only time we had a carry, right? So that is when we have identified that there is a carry. So we have identified that there is a carry using the AND operator, but we're not done yet. Like that's just the carry at that position. Now we need to bring it over to the next position, okay? So that's where we need to use the shift operator to shift it to the left one place. So putting it all together, we have XOR that takes care of the addition portion, disregarding the carry. The carry portion is where we use the AND operator plus the shift to bring it over to the next position. So putting all that together, we're going to keep going. We're going to keep using those operators until there is no more carry. And that's how we're going to do our addition. In this example, we have 5 plus 6. Okay, so 5 represented in bits is this over here, 0, 1, 0, 1. 6 represented in bits is 0, 1, 1, 0. First round, what is the sum? Well, we remember to do an XOR operation on the 2 bits here. And we get as a result 0, 0, 1, 1, which is just 3. So that's the sum portion of it, okay? So that's what we need to record here. And we also need to record and we need to get the carry. So how we do that is using the AND operator and shifting left once. So when we take those 2 bits again, do an AND operator, shift it left to the 1, then we get 1, 0, 0, 0, which is 8. Great. Now we need to add that carry back to the sum. Okay, so that's why we need to do the same thing. Okay, so we need to do an XOR on 0, 0, 1, 1, XOR 1, 0, 0, 0. The result is 11. Over here, the carry is now 0, 0, 1, 1 and 1, 0, 0, 0 shifted to the left one position, and now it becomes 0. Now there is nothing, like there is no more carry left to add back to the sum. So we stop. And the final answer is 11. So the sum is 11 and the carry is equal 0. Let's take a look over here. We see that we have a while loop, right? We said we keep going until there is no more carry. So while b, the carry, is not equal to 0, we keep doing those two things. Like we take the XOR of a and b, we set that as the new sum, but then we need the carry, right? So what's the carry? Okay, the carry is just a and b shifted to the left. All right, so that's what we keep doing until there's no more carry left to add, and we just return a. So it's a pretty straightforward once you get the idea of what we need to keep doing and why we need to stop when the carry is no longer there's nothing left to add back to the sum. The complexity of this, well, we can think of this while loop, right? The while loop keeps going, keeps shifting when the carry, like there's some carry left over. We keep like putting it to the left, right? We keep adding it. So at most in an integer, it's 32 bits, so it's big O of 1. And the space complexity is also big O of 1 since we just have some equals here. I hope that made sense, and thank you very much for checking this video.